Okay, so in 5-8, we're going to learn about another theorem. And what this will do is give us another strategy for solving or finding zeros. Okay, we've already talked about Descartes' rule of signs. That'll narrow it down. Okay, but then this will help narrow it down even more. So basically what the rational zero theorem says is that your possibilities for zeros can be found by taking the factors of the constant and dividing them by the factors of the leading coefficient. And this they call P, and this they call Q. Okay? So if we took all the factors of 40 and all the factors of 6 and divided them all out, positive and negative, that would tell us what our choices are, rather than just having to come up with just any old number. Okay? All right, so let me, the best thing to do is just go ahead and do an example. So example 1A. Now on this one, all we're going to do is list the possible rational zeros. So you need to write this down. 4x to the 5th plus x to the 4th minus 2x cubed minus 5x squared plus 8x plus 16. And we want to find all the possible rational zeros. Now, rational, that doesn't include imaginary, and that doesn't include zeros that have square root answers. Okay, it only includes fractions and integers, both positive and negative. But those are the ones that we try when we do synthetic division anyway, right? So our P is the constant. That would be 16. Our Q is the leading coefficient, which here would be 4. Your leading coefficient is always the coefficient of the term with the highest exponent. So if they're in order, highest to lowest, then that front number is your leading coefficient. Now, if they're not in order, then your leading coefficient will be somewhere else. But most of the time, they're going to be in order, and if they're not, I suggest you put them in order. It makes it a lot easier. All right. So what the rational zero theorem says is we can take the factors of P over the factors of Q. And when we do that, we've got to do both positive and negatives. Okay? So the first thing we're going to do is we want to list our factors of P. Well, what is our P? 16. What is our Q? 4. But it's not just 16 over 4. We've got to list all the factors of 16 and 4. So what are the factors of 16? 1, 2, 3, 4. What goes with that 2? 8 and 16. Okay, what are the factors of, this will be positive and negative. What are the factors of 4? 1, 2, 4. Okay, so all of our possibilities are going to come from dividing the numerator by the denominator, but we've got to do every combination possible. So what's 1 divided by 1? So plus or minus 1, and you always consider the positive and the negative. All right, now 1 over 2. 1 over 2. 1/2. Isn't 1 over 2 1/2? Now 1 over 4. 1/4. Okay, now go to the 2. 2 over 1. 2. Plus or minus 2. 2 over 2. 1. We already have that one. So you don't have to do it again. 2 over 4. 2/4, which is the same as 1/2. We already have it. All right, now go to the 4. 4 over 1. 4, so plus or minus 4. 4 over 2. 2, we already have it. 4 over 4. What? 1. We already have it. Okay? 8 over 1.
8.
So plus or minus 8. 8 over 2.
4.
4, which is already there. 8 over 4. 2, which is already there. All right, 16 over 1. Plus or minus 16. 16 over 2. Quickly. 8, already there. 16 over 4. 4, already there. All right, so our possible rational zeros are these. And every one of them, it's the positive and the negative. So I didn't make you write down 1, -1, 1/2, -1/2. We could have. So that means there's 2, 4, 6, 8, 10, 12, 14 possibilities. Okay? Now, if we were going to be completely solving, then we would go from here and we would do Descartes' rule of signs to find out what kind, how many positive and negatives we have, and go from there with our synthetic division. So what this does is gives us another strategy to help narrow down the possibilities. Okay? So let's do one more like this one, example 1b. F of x equals x cubed plus 11x squared plus 24. Now, somebody asked a while ago, there's a missing term, the x. Do we need to put it in? Do we need to put a 0x in? What are we going to be using? We're going to be using this and oh, what is our coefficient here at the front? We're not even going to be using anything in the middle, so no, you don't have to do that. Not for this. Now, if you got ready to do synthetic division, yeah, you'd have to put a 0 in it. But on this one, we're not doing that. We're just listing the possible rationals. All right, so we're going to do P over Q. What's your P? What's your Q?
1.
So, what are the factors of 24?
1.
And if you want to do them in pairs, you can. 1 and 24. I like to do them like that. Then what? 2 and 12. Then 3 and what? 8. Next. 4, 6. Anything else? Well, when you get to 6, it starts back over. So that's it. I kind of left a little bit too much room. Now, what are your factors of 1? So, basically, in this one, what are your rational zeros going to be? Your possibilities. It's going to be these up here, right? Because if you divide them all by 1, that's what you'll get. Now, on this one, I'm just going to list the plus or minus. I'm going to be lazy at the front, but you need to know that it goes with every one of them. So if your denominator is 1 or your leading coefficient is 1, it's going to be the factors of this number, which that's what this corollary says. It goes to a bunch of words, but it basically says that if you have a leading coefficient of 1, then your possibilities for rational zeros will be factors of the constant, which that's what that shows right there. Okay. So again, if I were going to try to solve this, then I would do my Descartes rule of signs and go from there. So this just adds another strategy to help us narrow it down. So we're going to get into one now that we're going to do together. It's a real life one. And this one is pretty detailed. And once we get through this one, any that you'll be asked to do on your own are going to seem like piece of cake. Okay? So, I just went. Adam is helping his younger brother build a diorama for a school presentation. The diorama is a rectangular prism and will be 8,019 cubic inches. The diorama will be 24 inches longer than it is wide, and the height will be 18 inches greater than the width. Find the dimensions of the diorama. So what are dimensions? What does that mean?
Each side.
In a box, what would that be? Length, width, and height. Okay? So we're trying to find length, width, and height. All right? Now, what is this 8,019 cubic inches? What does that represent? What's measured in cubic inches? Starts with a V. Volume. Okay? So the 8,019 is the volume of this box. Now, we know that volume is length times width times height, right? You should remember that. All right. The diagram will be 24 inches longer than it is wide, and the height will be 18 inches greater than the width. So let's start with the width, and let W be the width. So then my length is 24 longer than it is wide. So what would my length be in terms of W? It'd be the width plus, it's 24 inches longer than it is wide. So the length is W plus 24. It's the width plus 24. Height, it's in terms of width also. So it'd be W what? It's 18. Says the height is 18 inches greater than the width. So basically, we're going to write an equation here to get our function. So we know that V equals length times width times height. Our volume is 8,019. Now, if I do length times width times height, I'll have W plus 24, which that'll have to go in parentheses, times W times W plus 18. These two I really want together. So can I change the order? Do I have to do the length, width, height, or can I do width, height, length? Or it's multiplication, so I can switch it around, right? So I'm going to put the width first, and then put the length and height. Now, what I want to do now is I want to FOIL this. So W times W is W squared. Outside, W times 18. 18W. Inside, 24 times W. And then 24 times 18. Yeah, somebody needs to have a calculator out because we're going to need it. In fact, everybody's going to need it here in just a minute. 432. Now, before we start multiplying by W, let's combine some like terms here. So, 18W plus 24W is what? 42W. Now I'm ready to multiply by this W out here. So I've got to distribute this W. So I have 8,019 equals W cubed, that's W times W squared. W times 42W would be 42W squared. And then W times 432 would be 432W. Now, to get my function f of W, I really want to set it equal to 0. So I want to subtract 8,019 from both sides. So my function ends up being W cubed plus 42W squared plus 432W minus 8,019. Because I subtracted it from both sides. So this is my function I'm working with. And so I'm trying to find the width. I'm trying to find W. Once I have W, then I just add 24 to it to get the length and add 18 to it to get the width. I mean the height. Okay? So, what I'm going to do now is I'm going to use the rational zero theorem to find the possible zeros. The rational zero theorem is what we just talked about on the page before, where we do P over Q. Okay? So, P, you're going to have to write small or you'll end up having to use another sheet of paper. P over Q. All right, so what's my P? 8,019. Now, do I need to worry about the negative? No, because when I do P over Q, I consider positives and negatives anyway. So, 8,019 over, what's our Q? 1. So basically, my answers or my possibilities are just going to be the factors of 8,019, right? Because they're all going to be over 1. So now here is where we need to do some work. We're going to have to find all the factors of 8,019. So how do we do that? It's on the back wall if you've forgotten. Go to graph. So you go to graph, then you do what? 8,019 divided by X, and then what do you want to look at?
Your table.
The table. Control T. So I'm going to give y'all a minute. There's quite a few of them. Now, how are you going to know if they're factors or not? Should you see any decimals if they're factors? No, you're looking for integers, whole numbers. You got them? Where are you going to get them at? You need to find them. We may sit here till everybody has them. Because if you don't do it now, you may not know what to do when you have to do it on your own. Y'all find quite a few? Are you writing them down as you go? Oops, I left out a couple of them. Now, if you're watching the video, you can use your fast forward if you need to. No, I'm talking to the people watching the video. That will be watching the video. I'm talking to the future watchers.
Yeah, 149, 11, 27, 33, 81. 243, and then 297, and 729, and 891, and 20,673, and
Is that all of them?
Yeah.
And remember, it's plus or minus, but I didn't write the plus or minus in front of it. A lot of it. Now, did you scroll all the way down to 8,019? How'd you know when to stop scrolling?
I was no. Okay. You did
Here's how
8,019 clicks.
Here's how I did it. Here's how I knew I was done. Because I had 81 over here on the left side. So here's 81 and what was right beside? 99, right? So I wrote that down. Then I kept scrolling, and guess what the next one I came to was? 99, and guess what was over here? 81. So they were starting to repeat, so I knew I was done. See what I'm saying? All right. So that's step 1. Step 2, use Descartes' rule of signs to determine the possible number of positive and or negative real zeros.
Oh.
All right. So I'm just going to rewrite my function. W cubed plus 42W squared plus 432W minus 8,019. So count my sign changes. No. No. Yes. So how many positive real? Now, that could include irrationals. This only gives us possibilities for rationals. So what I'm hoping is that that one positive real is going to be a rational. And I believe it will be because I think irrationals kind of come in pairs, like complex, if I remember right. Okay. So then do f of negative w. Remember, only change the signs of the coefficients of the terms that have odd exponents. So you're actually only going to change 2 signs here. I got yes, yes, no. So that means there's 2 or 0 negative real. So there might be 2, there might be 0. So now we've got to think. Now, first of all, let's think to our answers. This is a real life problem, okay? It's not just a generic problem. So what kind of answers are we going to be interested in every single answer? Are we going to be interested in the positives, the negatives, and or the complex or imaginary? Think about that for a second. We're looking for a width. Positive, negative, imaginary. Which one or ones are we interested in? Only the positive, right? Because we're not going any negatives we would throw out because you're not going to have a negative width. And any complex or imaginary we're going to throw out. So all we're really interested in are the positives anyway for this problem. And since I know that there is one positive real, I wanted to start doing my synthetic division with positives. There might be 2 negatives, but there might not be any. So like I said, I'm not really worried about the negatives on here. We're not going to have to completely solve this one. All we got to do is find the positives. And there is only one. So once I find it, I know that's my answer. Now, if there was more than one positive, I would have to find both of them. So, what number do we want to start with? 1. 1 is always going to be right here, always. Now, if 1 doesn't work, are we going to try 2?
No.
Why? It's not up there. So see how this helps us narrow it down? Yesterday, we would have tried 2. But this right here helps us narrow it down so we don't have to try the ones that aren't going to work for sure. So let's try 1. Now, be sure you don't use the coefficients when you did f of negative w. So 1, 42, 432, negative 80, 19. So I only had to finish that one. It's not going to work. So what are we going to check next? What do you think we got to check next? 3? Now, if you notice that right here, that negative is going to be pretty far from 0, you might could think, well, 3 may not get me close enough. So you could try 9, but to be safe,
I don't want to do the same. We should do that.
if you want to do 9, you can. But if it doesn't work, you're going to have to be careful. All right, and I saw that wasn't going to work because 500 and something times 3 wasn't going to get me. It was going to be positive. And it wasn't going to be positive 8,000 something. So what worked? Are there going to be any more positives? No, because our rule of signs said there's only one positive real. There's not going to be any other positives. So I don't have to do my depressed polynomial and try to factor it or use quadratic formula. Now, I would if this was just a general problem. But because this is specific and we're only worried about the positives, then I've got one of my answers. The question said find the dimensions of the diorama. How many answers am I going to have? What are dimensions? You said it earlier. Length, width, and height. So we want the length, the width, and the height. So the width is 9, right? Because that's what we solved for. We solved for the width. And that would be inches, I believe. Yep. So what's the length? It's the, go back up here, width plus 24. So 9 plus 24 would be what? And then the height is width plus 18.
It's kind of weird. Those, I guess they should be.
So that box is 33 inches long, 9 inches wide, and 27 inches high. Now, we can double check and make sure that's right. Do 9 times 33 times 27 real quick. Do length times width times height. What should you end up with? What was our original volume that was given to us? 8,019. Did we get 8,019 when you do 9 times 33 times 27? Yes. Okay, now that's as far as I got with second period.
Thank the Lord.
So we'll stop there with y'all too. So we will continue this lesson tomorrow.